subtracting rationals. So we did equivalent rationals. Equivalent rationals were when you had to multiply the top and the bottom by the same thing, or you could divide the top and the bottom by the same thing, right? Simplifying, you went to the tops and you took out GCF or difference of squares, which is the numerator, and then you went to the bottoms, GCF and difference of squares, and then you stayed MPVs, and then if there was anything that was common, you canceled it off. Multiplication, you just got 2 rationals instead, but you did the same thing. Simplified, or GCF, and then you stayed MPVs for the denominators and canceled off if there's anything on the top that matched anything on the bottom. Division was the exact same thing, but you had to flip the right-hand side and add the extra MPV, right? Now, we're not simplifying that way anymore. With adding and subtracting, what do you need in order to add and subtract fractions? Yeah, the common denominator. So the way we're starting off at the beginning, it's more simple because I actually gave it to you. So then we're going to get to ones where you have to make it a little bit more complex. Then we're going to get to ones where you have to actually make it be rational expressions where you have a binomial on the bottom. Okay? So let's look at the first one. It says simplify. When it says simplify, it said simplify when it was multiplying, dividing, simplifying, right? Or adding and subtracting. The only thing you know, only reason how you know what to do is you look and see what symbols between them. And in this case, it's subtraction. If there's subtraction or addition without an equal sign, which there isn't an equal sign in this, right? We'll put an equal sign because we're going to say each expression is equal to each. It's not an equation because there's no equal sign. So what we're going to do is we're going to make each expression equal. But we need to have common denominators first. What's great about this one? It already does. So what we can do once they have common denominators is you can write them over that denominator. Now we're going to get 2x minus x. Now some people put it over like 6 or 9. What's the point of getting a common denominator if you're going to change the denominator? There is no point. So once you get that denominator, write it down. Okay? Now we have 2x minus x. So we can put those together because they're common terms. So like what's 2x minus x, or 2 apples minus 1 apple? 2. Ooh. 2 apples minus 1 apple. 1. No.
Oh, I guess because there's a 1 in front of that. On the recording, David. Gotcha.
All right. So 1x over 3. Do we have any non-permissible values? There are no non-permissible values because why? There's no variables in the denominator. Okay, let's look at the next one. These are both over 5, so we can write it all over 5 right off the bat. We have 2a minus 3 plus 9a plus 1. Now, we can collect like terms. Like terms have the same variable, right? So if it was a 2a and a 9a squared, you couldn't put them together because they'd be different. But they're both 2a's, or both a's. So 2a plus 9a is 11a. And then negative 3 plus 1, negative 2, all over 5. Any MPVs? Nope, because right now we don't have any variables in the denominator. C is an easier one. D has a catch, so we're going to go along here. So C, they're all over what? 4. And then we can write our numerator over it. So 3x plus x, which is actually 4x over 4. Are we done? No. Because the 4x is like 4 times x. So we can cancel those 4's off, and we actually just get x. And we can cancel them off because there's no plus or minus signs in between them, but also because there aren't any MPVs. If not, we'd have to say the MPVs first. Why is there a catch on D? Let's write it out and you tell me what I'm doing wrong. So you have 5y minus 1 over 6 minus 4y plus 7 over 6. So I'm going to write it all over 6. And then I'm going to go 5y minus 1 minus 4y plus 7. Put what together? Right now, what am I only subtracting? The 4y. Above, what am I subtracting? The whole rational. So am I actually doing what it told me to do above? No. So remember, when you're subtracting this off, you're subtracting 4y, which I already have, and you're subtracting 7. So what should this actually be? A negative 7, not a plus 7. Because you're actually subtracting both those terms. Does that make sense? You have to subtract the 4y, and then you have to subtract the positive 7. Now, what if it was a negative 7? What if you subtracted a negative 7? What would you actually be doing? Adding. Okay, now we can collect like terms. So we have to remember to distribute this subtraction to both those terms because we're actually subtracting both of them. Everyone forgets that. Don't be that person. Okay? Now, we have 5y minus 4y is y. And then negative 1 minus 7, negative 8, all over 6. No MPVs because we don't have any variables in our denominator. What's wrong with example 2? We got to get common denominators. The only way we can get common denominators is by making the denominators either the same as what they are or bigger. You can't make the denominators smaller. You can't divide to get down to them, but you can multiply. So what's common to 4 and 3? 12. So I have equal to 3x over 4 minus x over 3. What do I need to multiply the left by? 3. Now, can I just randomly multiply the bottom by 3 and be good? No, you have to do it to the top as well. And the reason why is you're actually multiplying by 3 over 3. When you multiply by 3 over 3, what's that just multiplying by? No, 3 over 3 is 1. When you multiply anything by 1, does it change it? Like when you were in elementary school and they went 7 times 1, you said it was 7, right? Multiplying by 1 doesn't change the expression. So that's why we have to do it to the top and to the bottom, because then we're just multiplying by 1. If we don't do it to the, if we do it to just the bottom and not the top, then we're actually multiplying by 1/3. When you multiply something by 1/3, does it change it? Yes. So we have to do it to the top and the bottom. Now this one, we have to multiply by what to get 12? 4. So it's just that extra step in there, right? So now we're going to have 3 times 3x, which is 9x, over 12, minus x times 4, which is 4x, over 12. And now what can we do? Now we can minus them because we have common denominators, which is what we need when we're doing adding and subtracting. So it's all over 12, and we get 9x minus 4x, and 9x minus 4x is 5x. And we still don't have to state MPVs because we do not have a variable in the denominator. Now B, we have 3 and 6. So some people say, well, I'll just divide the second one by 2. Can I divide to get common denominators? No. So I'm going to have to multiply. What common denominator can I make them both be? 6. Okay? Never divide to get a common denominator. Never, 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 never. So I have equals 3a minus 1 over 3. And you guys told me I have to multiply it by 2 because I need to get 6 on the bottom. And then what do I have to do to this one? Nothing. I could just multiply it by 1, but that would be silly. So I'm just going to not multiply it by anything. But you could technically do 1 and 1. What do I have to remember to do with that 2 in front of the 3a minus 1? Times what, though? The whole thing. So some people will just put the 2 to the 3a. That's not right. You're multiplying this whole numerator. You're multiplying the whole 3a minus 1. So you're going to go 2 times 3a, which is 6a, and then 2 times negative 1, which is negative 2, all over 6, plus 4a plus 5, all over 6. And now that we have a 6 in the denominator, we can put them together. It's just like above, right? So it's all over 6, 6a minus 2 plus 4a plus 5. Why don't I have to distribute the plus into the 4a plus 5? Why don't I have to distribute that addition sign in? I had to do it with subtraction. Why don't I have to do it with addition? Yeah. When you subtract, what does it do? It changes the signs after it, right? when you do addition, when you distribute a plus 1, does it change signs? No, that's why. So now we can collect like terms. 6a plus 4a is 10a. Negative 2 plus 5, positive 3, all over 6. You guys try C. Yeah, you do. What's common to 8 and 3? 20, close, 4. 24. So the first one, the left-hand side, we're going to multiply by 3. Oh, it went back to the other marker. 8y minus 3 over 8 times 3. And if you want, you can put that binomial in brackets so that you remember to distribute it to both. And then it's going to be 8. So on the top, we're going to end up with 24y, which should be equal to 24y minus 9 over 24 minus 16y plus 8 over 24. So if you're someone who forgot to distribute it in, write yourself a little side note with like a little star saying, remember to distribute the number into both terms. Okay? Now, if you're the next person who forgot to distribute the subtraction sign into both terms, to remember to subtract both terms, leave yourself a star again. So this is going to be over 24, and we're going to have 24y minus 9, and then we're subtracting 16y, so we get subtract 16y, and then we're subtracting a positive 8. So it's actually going to be negative 8. If you forgot to do that, if you forgot to subtract both terms, leave yourself a note and remind yourself not to do that. Now, 24y minus 16y is 8y. And then negative 9 minus 8 is negative 17, all over 24. Okay? So I'm going to give you some to practice. And because we're going to go advanced into ones where the bottom's going to be like 4x and the other one's going to be 4x or 8x squared. Or we're going to do ones where one bottom's x plus 2 and the other bottom's x minus 3. Okay, so it's going to get more advanced. So I want you to practice this so that you get the skills where you remember to distribute it into both. Or you remember to distribute the subtraction sign in. Because when it starts getting harder, you need to be able to do that stuff very easily and not oops on that. Okay? Oops.